Purpose of this video is for you to be able to describe ways to determine acidic or basic solution's identity. Let's say Dr. Square and Crazy Hair have a solution. Put some pH paper in it and they know it's an acid or a base, but they don't know what acid or base it is. Now, before we get started, we're going to need to know some key terms. And key terms, a solution is where you've got a homogeneous mixture and the two substances are in a single phase. This is typically a liquid like salt solution. Tap water is another solution. Hydronium ions are H3O+. They're acidic ions that are found in the solution. Hydroxides are OH negative and they're in basic solutions or more concentrated in basic solutions. Soluble means able to be dissolved or can be dissolved, like salt is soluble in water. Insoluble is when it can't be dissolved, and that's like a piano in water or wood in water. Now, and a precipitate is a solid that's going to form when you mix two solutions. Now, the first method is to test pH. So we stick in, and we know how acidic or basic is. And we would compare our results to the pH scale. Now the pH scale goes from 0 to 14. 7 is in the middle. From 0 to 14 are acids, and 7 to 14 are bases, and 7 is neutral. And what that means is the further you get out, the more hydronium there are. Like the further you get out towards 0, the more hydronium, H3O+. The other way, there's more hydroxide, because as you go to the left, it gets more acidic on this image, and on the right, it gets more basic. And you have less hydroxide and less hydronium. And if you're at 7, you've got equal amounts of both of those ions. Now, you could compare the pH scale to, let's say, Dr. Square and Crazy Hair's feeling scale, where they've developed this from 0 to 2. 0 is hating things, 4 is loving, and 2 is neutral. And the reason they came up with this was so that they could talk about things in code. So this dog, Dr. Square, is like a 3.2. So if Crazy Hair understands that to mean he kind of likes him. Now, let's say Dr. Square says, oh, this house is a 0.3. Therefore, Crazy Hair can interpret that as, man, that place must be really bad. Dr. Square must not like it. And on the converse, if Dr. Square says circle is a 4, that means it's love. He really loves, or Dr. Square really loves that thing that he's rating as a 4. Now, to get back to solutions, let's say Dr. Square and Crazy Hair put some paper in the solution, and they get a reading as to not just any paper, that put hydronium or pH paper into the solution, and they get a reading. If it's a 1, then they know it has to be a really strong acid, like HCl or H2SO4. On the converse, if they've got a solution and they put some hydronium in it and it turns blue, they compare that to the scale and they say it's a 9, it may be baking soda or dilute NaOH. This really should be a base, not an acid. I meant to change that. There's a little error there. So that's the first method of determining what the acid is. Basically, you're testing the pH, testing how much hydronium hydroxide you've got in there. Now, the second method is to test for a precipitate. And that's when you add a solution to another solution in hopes of making a precipitate. And a precipitate is an insoluble compound. And this is kind of what it would look like. You've got your unknown acid. Let's just pretend it's a strong acid. And I've got this known solution, something I know what it is. Now let's just pretend they're clear. I know they're colored, but let's just pretend they're clear. You add a couple drops of the orange solution to the gray solution, and you've got two outcomes. You can make a solid, and if you made a solid, it'd form this cloud, which would eventually settle, and that thing is called a precipitate. And if you didn't, then you've got no reaction. Now, how this all gets interpreted, you mix the chemicals and you've got two outcomes. You can make you can not have a precipitate, and what that means is that there's no insoluble chemicals present. On the converse, you can make a precipitate, and that's where you've got some insoluble compound there. This is what it would look like in lab. You've got this base that you don't know what it is. It's got a pH of 9, and you have these two ideas what it could be. So you add a couple drops of another solution to it, and nothing happens. Therefore, you're able to determine that it's dilute NaOH because of a lack of a reaction.